Okay, again, good morning to all of you. Welcome to our virtual class for Principles of Operating Systems and its Applications. So right now, we will continue our discussion on week 1, which is network infrastructure and components. On your lesson 8, we have understanding adapters, hubs, and switches. What is a network adapter? Transmission speeds, what is a hub, the characteristics of a switch, and what is a VLAN. So what is a network adapter? So a network adapter, it converts instructions from the network protocol stack into electrical signals. It merges these signals onto the wire, and it converts electrical signals received on the wire into meaningful instructions for the network protocol stack. So the network adapter, we all know that it is a piece of hardware that acts as the interface for a computer to a network. So this is way computers can communicate across a network. So the network adapter allows the device to communicate over the local area network, connecting to the internet or to other computers. So the network adapter encapsulates the instructions it receives from the protocol stack into a logical sequence known as a frame. The protocol stack or network stack, it is an implementation of a computer networking protocol suite or protocol family. So the set of protocols used in a communications network. The protocol stack is a prescribed hierarchy of software layers. So starting from the application layer at the top, so the source of the data being sent to the data link layer at the bottom, transmitting the bits on the wire. So the protocol stack refers to a group of protocols that are running concurrently that are employed for the implementation of network protocol suite. So the protocols in a stack determine the interconnectivity rules for a layered network model, such as in the OSI or TCP/IP models. So figure shows the IEEE 802.3 frame structure. So the preamble and the start frame delimiter fields. So the preamble consists of 7 bytes, and start frame delimiter or the SFD, also called the start of frame, which is 1 byte. So fields are used for the synchronization between the sending and receiving devices. So these first 8 bytes of the frame are used to get the attention of the receiving nodes. So an Ethernet frame format. Okay, so it is the IEEE 802.3 standard. So the Ethernet frame format. So first is the preamble. So the Ethernet frame starts with 7 bytes preamble. So this is a pattern of alternative zeros and ones, which indicates starting of the frame and allows sender and receiver to establish bit synchronization. So initially, the preamble was introduced to allow for the loss of a few bits due to signal delays. But today's high-speed Ethernet don't need preamble to protect the frame bits. So the pre or the preamble indicates the receiver that frame is coming and allow the receiver to lock onto the data stream before the actual frame begins. And then we have the start frame delimiter. The SFD, this is a 1 byte field, which is always set to 10101011. So the SFD indicates that upcoming bits are starting off the frame, so which is the destination address. So sometimes the SFD is considered the part of the pre. Okay, this is the reason the preamble is described as 8 bytes in many places. So the SFD warn station or stations that this is the last chance for synchronization. Then next we have the destination address or the MAC address. This is 6 byte field which contains the MAC address of machine for which data is destined. And the source address, of course, this is also a 6 byte field which contains the MAC address of source machine. So a source address, it is always an individual address or unicast. So the least significant bit of first byte is always 0. And then the data, this is the place where actual data is inserted, also known as the payload. So the payload, both IP header and data will be inserted here if internet protocol is used over Ethernet. So the maximum data present may be as long as 1,500 bytes. So in case data length is less than minimum length, which is 46 bytes, then padding zeros is added to meet the minimum possible length. And then finally, the checksum. So field uses as the polynomial code. So that is the Ethernet or the IEEE 802.3 frame format. And then next we have the transmission speeds. So the term bandwidth is used to describe the transmission speed of a network. So early Ethernet operated at 3 megabits per second. Today's Ethernet is typically 1 gigabits per second. The contention reduced throughput. So when we say a transmission speed, ito yung rate at which data packets across a computer network from one server to another. So ang transmission speed is typically measured in megabits per second or Mbps, which equals 1 million bits per second. So although gigabit and even terabit speeds are becoming common, the transmission speed, it is the rate, okay? It is the rate at which data are moved across a communication channel. So bits per second is a standard way to measure data transfer rates, such as a network connection and internet download speeds. Okay, so what is a hub or a network hub? So it enables star wiring to provide a central wiring point. It supports multiple ports, provides for a degree of fault isolation. It extends your network. So ang hub or an Ethernet hub or a network hub or simply a hub, it is a network hardware device for connecting multiple Ethernet devices. So together and making them act as a single network segment. So a hub is a node that broadcasts data to every computer or Ethernet-based device connected to it. So a hub is less sophisticated than a switch. So a switch, it is of course a networking device that connects devices on a computer network by using packet switching to receive and forward data to the destination device. So a network switch, it is a multi-port network bridge that uses a MAC addresses to forward data at the data link layer of the open system interconnection model. So the different layers of the OSI model has 7 layers: the application layer, the presentation layer, session layer, the transport layer, network layer, data link layer, and physical layer. So among which layer 2 and layer 3 refer to the data link layer and network layer respectively. And the switches working in these layers are called the layer 2 switch. So the characteristics of a switch. So ang switch provides the same basic functionality as a hub. So a switch provides wiring concentrator functionality like a hub. So it enables network traffic management. It performs firewall functions. It makes routing decisions based upon traffic priority. So we have different types and description. In layer 2, which is MAC level bridging. So in the OSI model, bridging is performed in the data link layer, which is layer 2. So if one or more segments of the bridge network are wireless, the layer 2 bridging works by putting one physical and one virtual Ethernet adapter into a mode where they can receive traffic that is not destined for their address. So this traffic is selectively sent onto the other network according to the IEEE 802.1D standard known as bridging the frames. And then in layer 3, so it's for routing functionality added. So simply put, a layer 3 switch combines the functionality of a switch and a router. So it acts as a switch to connect devices that are on the same subnet or virtual LAN. So at lightning speeds and has internet protocol routing intelligence built into it to double up as a router. So a layer 3 switch is basically a switch that can perform routing, routing functions in addition to switching. So a client computer requires a default gateway for layer 3 connectivity to remote subnets. And then another type, we have layer 4 for firewall and QoS or quality of service support available. So layer 4 or layer 4 firewalls or session filtering firewalls. So in addition to the ability to actively track network connections and allow deny traffic based on the state of those sessions. So that is stateful packet inspection. So in layer 4 for firewall and quality of service support. And then next, what is a VLAN or a virtual LAN or virtual local area network? So a VLAN enables you to manage network traffic, group physically dispersed nodes into logical LANs. It increases the number of nodes without needing to rewire the network, reconfigure the network without needing to move nodes, isolate network traffic. So figure shows an example of a virtual local area network. So it is a subnetwork. So which can group together collections of devices on a separate physical local area networks or LANs. So ang LAN, it is a group of computers and devices that share a communication line or wireless link to a server within the same geographical area. So a VLAN is associated with a broadcast domain. So the VLANs or virtual local area networks, it is a technology that allows you to split a home network into segments using low-cost switches. So generally, a switch will send broadcast traffic to all connected ports and will allow devices connected on any port to communicate with any other device. So VLANs allow network administrators to automatically limit access to a specified group of users by dividing workstations into different isolated LAN segments. So ang VLAN, it is a set of end stations and switch ports that connect them like a bridge. So a VLAN switch forwards traffic based on the layer 2 header. So which is fast, like a router. It partitions the network into logical segments, so which provides better administration, security, and management of multicast traffic. So the VLAN stands for Virtual Local Area Network or Virtual LAN. Okay? So it is a custom network created from one or more existing local area networks. So it enables group of devices from multiple networks, so both wired and wireless. So to be combined into a single logical network. So on your lesson 9, understanding routing. So what is a router? How a router determines a destination, the common routing protocols, and then discussion, select a suitable routing protocol. So let us define first what is a router. So a router manages network traffic by only forwarding packets when required, and it supports one or more routable protocols such as the Internet Protocol. It receives explicitly address frames from network nodes. It makes routing decisions based on the information maintained in its routing table. So when we say a router, of course, it is a networking device that forwards data packets between computer networks. So the routers perform the traffic directing functions on the internet. So data sent through the internet, such as a web page or an email, so is in the form of data packets. So ang router helps you connect the multiple devices as shown in the given figure. It helps you connect multiple devices to the internet and connect the devices to each other. So also you can use routers to create local area networks of devices or LAN. So these local networks is very useful if you want to share files among devices or allow employees to share software tools. And the gateway, it is a network node that serves as an access point to another network. So it involves not only a change of the addressing, but also a different networking technology. So the router also has a default route configured to a device on a adjacent network, one hop closer to the public network. So the gateway is a single device that can do the jobs of both a router and a modem. So if you own a dual router and modem device, then it will connect your internet service provider network to your local Wi-Fi network or Ethernet. So this combined with a phone service in the same hardware device. So ang router, it is a device that is capable of sending and receiving data packets between computer networks. So also creating an overlay network. So ang gateway, on the other hand, joins the similar systems. So it is defined as a network entity that allows a network to interface with another network with different protocols. So the default gateway is the path used to pass information when the device doesn't know where the destination is. So more directly, a default gateway is a router that connects your host to remote network segments. So how a router determines a destination? So we all know that the primary function of a router is to determine the best path. So forward the packet to C12, okay? The best path to use to send the packets. So to determine the best paths, the router searches its routing table. So the routing table for a network address that match the destination internet protocol address of the packet. So if there is a default route, the packet is forwarded to the gateway of last resort. The routing table contains network, of course, or the next hop associations. So this association tell a router that a particular destination can be optimally reached by sending the packet to a specific router. So that represents the next hop on the way to the final destination. So the router connects multiple IP networks. So it determines the best path to send packets. So figure shows an example of to send packets to its destination. So a router accepts a packet and accesses its routing table. So we have routing table. The routing table is to determine the appropriate exit interface. So based on the destination address. So the different destination address, we have A, B, C, send to A1 or point 1 is the internet address, B.1 up to B.254. So the IP addresses is from 0 to 255, but the usable internet address is 1 to 254. So the router then forwards the packet out of the interface. So the routing table contains the network layer intelligence that tells the router how to forward packets to remote destinations. So initially, the routing table is made up of networks so that are directly connected to the particular router. So the routers add a directly connected route when an interface is configured with an IP address, okay, and is activated. So there are three ways for a router to learn routes. We have static routing, and also we have default routing. So this is the method where all routers are configured to send all packets towards a single router. So the routing table, it contains the information necessary to forward a packet. So along the best path towards its destination. So each packet contains information about its origin and destination. So the table then provides the device which with instructions for sending the packet to the next hop on its route across the network. The common routing protocols, we have the RIP, the OSPF, and the BGP. So the RIP or the IGP distance vector-based algorithm hop count, okay, greater than 16 unreachable rather. So the RIP, stands for the Routing Information Protocol. So it uses hop count to find the shortest path from one network to another. So where hop count means number of routers a packet must pass through on the way. So when a packet goes from one network to another, so this is known as a hop. Then another protocol, we have the OSPF. So IGP routing protocol links state-based skills better than the RIP. So the OSPF stands for the Open Shortest Path First. So it is a protocol, routing protocol is commonly used by network routers to dynamically identify the fastest and shortest available routes for sending packets to their destination. And then another routing protocol, we have the BGP. So EGP specifically designed to support the internet. The BGP stands for Border Gateway Protocol. So it is a routing protocol is used to announce which networks control which IP addresses and which networks connect to each other. So the large networks that make this BGP announcement are called autonomous systems. So the BGP is a dynamic routing protocol. So the RIP, the Routing Information Protocol, uses hop count. So successfully implemented the dynamic routing. Whereas the OSPF, it is an open shortest path first. It's a routing protocol developed for IP networks by the IGP Working Group of the Internet Engineering Task Force or the IETF. And the BGP, it is a Border Gateway Protocol. So it routes traffic between autonomous systems. So those are the common routing protocols, the RIP, the OSPF, and the BGP. Then next discussion and assignment is select a suitable routing protocol. So which routing protocol should you use? Then on your lesson 10, we have understanding media types. So when we say a media types or a media or a network media rather, it refers to the communication channels. So used to interconnect nodes on a computer network. So typical examples of network media include the copper coaxial cable, the copper twisted pair cables, and the optical fiber cables used in wired networks, and radio waves used in wireless data communications networks. So the network media is the actual path over which an electrical signal travels as it moves from one component to another. So on your lesson 10, we have understanding media types. We have coaxial cable, twisted pair cable. What are the CAT standards? The fiber cable. And then select a suitable cabling strategy. So the first media type, we have coaxial cable. Coaxial cables must be terminated. So when we say coaxial cable or coax, it is a type of electrical cable consisting of an inner conductor surrounded by a concentric conducting shield. So with the two separated by a dielectric, many coaxial cables also have a protective outer sheet or jacket. So as shown in the given figure, it is a coaxial cable. It is a type of cable used to transmit data, the internet, video, and voice communications. So coax cable is made up of an aluminum and copper shield with an outer plastic jacket. So see figure with the dielectric insulator helping to minimize the signal loss. So the types of coaxial cable. So we have the RG58. So it is fairly thin and flexible. So ideal for connecting nodes to the network. Does not support long cable runs on a large number of connected devices. Has an impedance of 50 ohms and uses 20 AWG copper wire. So the RG58, okay, it consists of 50 ohms. So it's for several thin strands of copper. It consists of several thin strands of copper. So this cable is thinner, okay, easier to handle and install than the RG8 cable. So this cable was used to connect a system with a backbone cable. So in Ethernet standards, this cable is documented as the 10^2 T-net cable. Whereas the RG59 as for the RG58, but with a slightly thinner or thicker rather 18 AWG core and an impedance of 75 ohms. The RG59. So it is solid copper. So it used in cable networks to provide short distance service. And then another is the RG11. So the RG11 is a thick coaxial cable with 75 ohms impedance. The 14 AWG cable provides the solid core. So the coaxial cable uses the RG rating to measure the materials used in shielding and conducting cores. The RG stands for the radio guide. So radio guide, coaxial cable mainly uses radio frequencies in transmission. The impedance is the resistance that controls the signals. So it is expressed in the ohms. And then the AWG stands for American wire gauge. So it is used to measure the size of the core. The larger the AW size, the American wire gauge, the smaller the diameter of the core wire. And then next, we have another type of media. We have twisted pair cable. So twisted pair characteristics, installation is comparatively inexpensive. Fault finding is easier due to the starward way in which the cable is laid. And the cable supports many uses, including data and telephony. So the twisted pair cable is primarily developed for computer networks. So this cable is also known as Ethernet cable. So almost all modern LAN or local area network computer networks use this cable, the twisted pair cable. So it consists of color-coded pairs of insulated copper wires. So every two wires are twisted around each other to form pair. So usually there are four pairs. So each pair has one solid color and one strip color wire. So solid colors are blue, brown, green, and orange in strip color. The solid color is mixed with the white color. So based on how pairs are stripped in the plastic sheet, so there are two types of twisted pair cable. We have the UTP and the STP. So in the UTP, which is unshielded twisted pair cable, all pairs are wrapped in a single plastic sheet. In the STP or shielded twisted pair cable, each pair is wrapped with an additional metal shield. So then all pairs are wrapped in a single outer plastic sheet. So the similarities and differences between the STP and the UTP cables.